some assignments yesterday, some practice questions on Simpsons on the group. Have both the groups got it?
Yes, sir.
Okay. So you can practice those questions. They are from the past papers. Any doubts? Any difficulties on any questions of the past papers? Or MMD papers?
सर अभी एक्सरसाइज खत्म हुई है, अभी आज से शुरू करेंगे सर पास पे.
Okay, okay, fine. ठीक है. So let me know if there are any difficulties which come up. All right. So let me come to. There are two questions of Hindship, which figure sometimes in your so I'm talking about question number 98 and 99. Hindship. Question number 98 and 99. Hindship. So काफी popular हैं ये questions. Angle of Loll के from Hindship. So question number 98. So just revising the formula. The formula for angle of Loll is tan theta is equal to root minus 2 GM initial over BMT. That's where the GM initial is the negative GM. So the GM is the negative initial GM. So the question says MV Hindship is floating at a displacement of 16,875 5.5 tons. This is the displacement. kg is 8.158 meters. FSM is 1798 PM. Assuming her to be a wall-sided vessel. Calculate the angle of Loll. Also calculate her GM at angle of Loll. So FSM is given to us. So FSC will be FSM divided by W. This will give me FSC. How much is it?
0.1065.
0.1065. So मैं 7 ले लेता हूँ, 3 digit. FSC is 0.107. Now, corresponding to this W, the KMT from the tables comes as equal to 8.260. And same way, the KB also comes as equal to 4.304. I'm just writing the values directly to save time. So KMT minus KG will give me GMT 8.26 minus 8.158. This will give me GMT solid. This will give me GMT solid. कितना आता है?
.102.
0.102 minus FSC minus 0.107 gives me GMT fluid. Negative 0.05. Similarly, KMT minus KB will give me BMT. KMT minus KB will give me BMT. So how much is the BMT?
3.956.
3.956. So I've got the values with me now. I can go into the table, into the formula. Tan theta is equal to minus 2 into minus 0.005 upon 3.956. So calculate the theta. How much is the theta?
Two
So
degree
2 degree
52.7.
Minutes. This is your angle of Loll. Is everybody getting the same answer? Is everybody getting the same answer?
Yes, sir.
Okay.
Yes, sir.
Next, the same question says, also calculate her GM at angle of Loll. Now, GM at angle of Loll for a wall-sided vessel is given by one formula. You can write down twice into GM initial into sec of angle of Loll. GM at angle of Loll is given by the formula twice into initial GM into sec of angle of Loll. Gives you the GM at angle of Loll. So put the values twice into 0.005 into sec of 2 degrees 52.7 minutes. So calculate the GM at angle of Loll. कितना आता है?
0.010.
Point. This is your GM at angle of Loll for a wall-sided vessel.
सर ये इनिशियल जीएम माइनस क्यों नहीं आया 0.005?
The value is 0.05, the amount, this thing. That is the quantum. The negative sign is indicative basically that it will take it to that particular. The value is 0.005 only. So we are only concerned about the quantum. The fact that it was negative took it to an angle of Loll. That's why.
तो सर फिर ये एंगल ऑफ लॉल पे भी तो सर ये नेगेटिव ही होना चाहिए ना सर जीएम?
नहीं, एंगल ऑफ लॉल पे वॉल साइडेड शिप में इट वोंट बी नेगेटिव. नहीं तो फिर तो वो तो सीक्वेंशियली चलता ही रहेगा, अनस्टेबल, एंड देयरफॉर it'll just keep on going. So because here we are talking about such small GMs, so these are only done in experiment stages in a test lab. Our merchant vessels, the GM at angle of Loll is going to be 0. That is the reason why they went to an angle of Loll in the first place, and they stopped there. Otherwise, they would have continued and they would have toppled over. But we know that our ships, they stop at angle of Loll because at that point in time they are in neutral equilibrium. We know that. All right. Let's come to question number 99. Question number 99. MV Hindship is floating at a draft forward 5.73 and draft aft 6.42. And she is at an angle of Loll, so theta is 4 degrees. FSM is 1563. Assuming the ship to be wall-sided, calculate her kg. Assuming the ship to be wall-sided, calculate her kg. So basically, you're given drafts, you have to calculate hydrostatic draft. So mean draft, trim, LCF for the mean draft, and then you calculate the hydrostatic draft. I'll write the I'll take it from the book directly. The hydrostatic draft is 6.071. So these are the values which you'll have to find out. Mean draft, trim, LCF for the mean draft, and then put it in the formula draft aft minus correction trim into LCF upon LBP. In case down by head, then the sign will be plus. For this hydrostatic draft, you have to go to the tables and calculate W. The W works out to 12,179.8 tons for that particular hydrostatic draft. Find also for that hydrostatic draft the Km. .419 is the Km. Find also the Kb from the hydrostatic draft. That will be equal to 3.241. So these are the various values which you get from the tables. Now you start off. Km minus Kb will give you BMT. So the BMT is 5.178. So therefore, you are given an angle of Loll tan 4 degrees is equal to minus 2 GM initial upon BMT 5.178. So therefore, find out the initial GM. Again, now the same thing you will say कि मैंने negative डाला है तो ये value मैं निकाल ही नहीं सकता. So what you are finding out is the GM value by squaring it, and that would give you the negative value, whatever you will get. So the GM value comes as equal to 0.013, and since she is at angle of Loll, therefore it will be a negative value. Again, FSC is equal to FSM upon displacement. So FSC works out to equal to 0.128. This what you got over here was a fluid one. So therefore, the GM solid will be a positive value. That will be equal to point 115, and this will be positive. The KMT which you got was 8.419 meters minus the GM solid will give you kg solid. .304 will be the kg solid. Hanji. Any doubts, anybody?
सर इस फेज 1 में कहाँ से कहाँ तक है सर एमवी हिंडशिप में कितने क्वेश्चंस तक है हमारा सिलेबस वैसे?
As far as stability is concerned, up to question number 99, and thereafter it goes into, as far as stability is concerned, up to question number 99, and then it goes into the grain cargo calculations.
सर ये मार्च बैच का ग्रेन कार्गो का हुआ क्या सर? क्योंकि आपने एक क्वेश्चन कराया था फेब के टाइम पे।
मैंने पूरा आपको करा चुका हूँ ग्रेन कार्गो. I had done the grain cargo with you.
नहीं सर, मार्च बैच के साथ नहीं हुआ ग्रेन कार्गो.
क्वेश्चन कराया था सर तब
बिल्कुल हुआ.
आपने, वो फेब
बिल्कुल
बैच के
कराया.
साथ
मैंने ग्रेन कार्गो कैलकुलेशंस कराई हैं. बिल्कुल याद करो.
सर एक क्वेश्चन तो कराया था वो ग्रेन कार्गो
बिल्कुल.
का, लेकिन उसके बाद आपने बोला था कि मार्च बैच के साथ हुआ, क्योंकि उसमें जो कंसेप्ट थे वो तो हमें क्लियर नहीं थे. जो
खाली एरिया, खाली एरिया कैलकुलेशन जो था, that was the only thing which was left.
नहीं सर, लैम्डा वाला भी वो कुछ पता नहीं सर हमें, लैम्डा क्या कंसेप्ट है.
अरे
नहीं सर, हुआ नहीं है ग्रेन कार्गो नहीं हुआ.
नहीं हुआ था. फेब के साथ एक क्वेश्चन हुआ था वो याद है, उसमें एरिया कैलकुलेशन भी था, लेकिन लैम्डा
so
का
the
जो
only thing which I had said was, okay, I'll do it again the next class if you're wanting me to, but then again the rest of the class will be this thing. Okay, I'll do that. I'll do that question again if that is the case. So because the grain cargo part of it is done by your cargo paper. That is this thing. I am dealing with the numerical, which comes as a numerical. Correct? So the only thing which I had left was the calculation of the area. How to calculate the area. I'll do it
सर
again.
ये जो लैम्डा इज इक्वल टू VHM जो था, ये VHM का कॉन्सेप्ट आपने बताया नहीं था, ये आपने बोला था बाद में बताएंगे। वॉल्यूमेट्रिक हीलिंग मूवमेंट जो था, इसका तो सर नहीं बताया था।
Volumetric healing moments are basically given for your grain calculations in the stability booklet. So you pick up the values from the book itself, the values, and then you use them. So I have one more class with you today. So in that I'll do it. If that is what you want, I'll do that. So basically, as far as stability is concerned, the Hindship questions are up to 99. And then after that, you have your tanker problems also. You have your tanker numericals. And you have your dry cargo numericals. Your draft calculations and everything also. So those are all from Hindship only, but they are from after 99.
Sir, from where to 99?
1 to 99. One to 99. I can't say question number 3 and 4 is not in your syllabus, because question number 3 and 4 form the very basic of your Hindship. Draft in hydrostat, draft in dock water, and displacement in dock water. That's how your entire Hindship starts. So some of your questions are from second mates के जो basics होते हैं, उसी की application है आगे जाके. But yes, generally जो questions आते हैं वो trim के होते हैं. So trim is after 72 onwards. Generally वहाँ से होते हैं. So that's why I normally say in the phase 1 class कि normally 60 के बाद से आप कर लो सारे. If you do it from 60 onwards.
सर इसके नोट्स मिल जाएंगे रिटर्न में? वैसे तो पता है इसका कि
किसके notes?
एक्सप्लेन द इफेक्ट ऑफ चेंज इन ड्राफ्ट ऑन केएमटी, एलसीबी, एमसीटीसी, एलसीएफ, कुछ है सर इसका रिटर्न में?
इसका जो है आपके पास में हिंडशिप पर्टिकुलर्स है.
यस सर.
तो हिंडशिप पर्टिकुलर्स का आपको कराया नहीं था मैंने, जब खोल के कराया था.
यस सर, वो तो कराया था सर, वैसे पूछ रहा हूँ.
तो आपको सारा आंसर आपको लिखवाया मैंने, आपको सारा आंसर बताया था आपको कि आपको हिंडशिप पर्टिकुलर्स को खोल के आपको वो कर्व एक्सप्लेन किया था. यस और नो? हिंडशिप पर्टिकुलर्स खोल के आपको वेरिएशन बताया था ना विद ड्राफ्ट.
यस सर, बताया.
So those are the answers. That is the what you have to. So Hindship particulars में से निकाल के you have to draw the curve and explain how the with draft increases, how the km variation happens, then how the TPC happens, how the LCF happens. ये सारा आपको कराया है मैंने भाई मार्च बैच को. याद है कि नहीं?
यस सर, कराया था.
So MCTC, then KB, LCB, सारे ग्राफ वाइज करके, तो वो you have to draw the same graph and you have to just explain that graph, how if draft increases, how the values change. Let me open it up.
एक्सक्यूज मी सर.
Yes, please.
सर एक आपने स्टैटिकल स्टेबिलिटी के टाइम पे क्वेश्चन दिया था होमवर्क के लिए, उसमें मेंशन था kg7 एंड अज्यूम kg इज 6.8 मीटर्स. उसमें क्वेश्चन में कुछ भी मेंशन नहीं था GGH cos थीटा के लिए, तो GGH cos थीटा हम लोग 0 ही अज्यूम कर लेंगे ना उसमें सब केस को.
That's right.
एंड इसमें से GGV डाउनवर्ड्स होगा ना 0.2 मीटर्स. Actual is 7 meters and 6.8 is assumed.
Actual is 7 meters, assumed is 6.8. So
Yes, sir.
GGV will be upwards.
Actual kg is given 7 meters and kg found is to be 6.8 meters.
हाँ, तो फिर उल्टा बोल रहे आप. तो the actual is 6.7 meters and found, that means the actual, that is 7 is the assumed then.
Okay sir, okay sir. So it will be 0.2 meters downwards, right?
0.2 meters downwards, correct.
Okay sir.
Let me know when you can see my screen.
Yes, I can see now.
Can see the screen, okay. So basically now what we are getting onto is, okay, if we are talking सबसे पहले draft in relation to TPC. So as the draft is increasing, we observe that the TPC is constantly increasing. So then we look at MCTC. As the draft is increasing, MCTC is also increasing continuously. Then we look at LCB. As the draft increases, now look at the LCB. It is increasing. It is increasing up to 4.4. It is increasing up to 4.6. It is increasing. Then at 4.6, it starts to decrease. The LCB, and then continuously keeps on decreasing. Okay? Now look at LCF. LCF is increasing. Then after 3.8, the LCF starts to decrease. Okay? Now look at KB. KB is always increasing. Look at KMT. It is decreasing. As the draft is increasing, the KMT is decreasing. It is decreasing. 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 At 7.6, the KM turns around and it starts to increase. Okay? So, what exactly is happening now? Basically, so this is the
सर एक डायग्राम दिखा दो जिसमें सब हम ये मार्क कर लें, जैसे KMD, KM लॉन्गिट्यूडनल और वो ट्रांसवर्स KMT और ये सब
I'm just showing you that. Can you see my screen?
We can see the graph.
Okay. So this is there with you already in your Hindship particulars. So this is your draft marks along the y-axis. And now this is your baseline. Now you look at the, this is your MCTC, this one. This is your MCTC. This is your TPC, which is going up. ये TPC है. Now I come to the this is the KMT. This is the KMT, transverse beta center. So it's decreasing, decreasing, and at a certain point it starts to increase. Reverse हो जाता है ये. So this is your, then this is your LCB. Now this is your forward, this is your aft, and this is your midship line. And your LCB was increasing, and at a certain point in time it starts to decrease. ये पीछे चला गया. So it is going aft. It's going towards midship. So this is your LCB with regards to your midship line, forward and aft line. So you'll be drawing this curve. Then your LCF. This is your LCF line. So this is your LCF line. And the same story happens at a certain draft. It starts to go back. So ये पीछे जा रहा है. So it is going, it first goes आगे and then it goes पीछे towards the midship. So this is your LCF line. So this is what you will draw basically with regards to midship, forward and aft. ये ग्राफ को कॉपी करके and then you will explain how basically it's happening and why is it happening. So So what is happening basically is, so let me know when you can see the screen, the plan view.
Yes, sir.
Okay. So basically what's happening is, when you are, when the draft has just crossed the rudder, that is the time. So till the draft was up to the rudder, the draft for this vessel must have been in the region of 3.8 or 4, whatever it was. So उसके बाद से जैसे ही you sink more, the aft waterplane area and therefore the aft volume starts to increase. Since the aft volume starts to increase, your LCB now starts to shift aft, and your LCF also starts to shift aft. That is why it starts going towards midship. पहले आगे था, forward of midship. So इसका midship is number 4, यहाँ पे है इसका. So it was forward of it. Then it starts shifting पीछे. That is the reason for it. So the reason why it starts to, the reason why it starts to, can you see my screen, the table?
Yes, sir. Yes, sir.
Okay. So the reason why basically what is happening is कि at 3.8, 3.6, when I said it is turning around. So what is happening at that draft basically? So somewhere around the 4.6 meter mark is जहाँ पे इसका रडर ट्रंकिंग आती है, और उसके बाद से the aft volume starts to increase, and so therefore you will find that the LCB starts to decrease from 4.6 onwards. Do you copy this? How this is happening? 73.019 तक तो इंक्रीज कर रहा था, 4.6 तक, बिकॉज पीछे की वॉल्यूम ज्यादा थी. उसके बाद से पीछे की वॉल्यूम बढ़ती रही. तो जो सेंटर ऑफ बॉयंसी है, जीसी ऑफ द अंडर वाटर वॉल्यूम, वो पीछे जा रही है. अब इट इज गोइंग टुवर्ड्स मिडशिप. डू यू कॉपी दिस?
Yes, sir.
Okay. Now, so this is the reason for it. So just explaining all this in your own words is what will be required when you write. KMT के लिए लिखोगे KB plus BMT is equal to KMT. And so therefore you'll explain as the draft increases, the KB increases. The BMT जो है basically why at 7.6 is it occurring and why it is changing? Because it is somewhere here, यहाँ पे इसकी load water line है. So इसकी load water line यहाँ पे है. So जैसी इसकी load water line आती है, उसके बाद से इसका ये टर्न अराउंड कर जाता है KMT इसका, और फिर ये KMT बढ़ने लग जाता है. So that is what you will explain for KMT. तो ये मोस्टली KMT का आता है, LCB का आता है, कभी MCTC एंड TPC का आ जाता है. ये 3-4 ये वाले पॉपुलर हैं काफी सारे.
ठीक है सर. MCTC तो सर इंक्रीज ही होगा ना, ये तो इसमें क्या लिखना है फिर?
ये TPC जो है उसमें इट इज डायरेक्टली प्रोपोर्शनल टू वाटर प्लेन एरिया एंड डेंसिटी. सो जैसे ही वाटर प्लेन एरिया बढ़ता जाएगा, जैसे ही ड्राफ्ट बढ़ रहा है, वाटर प्लेन एरिया बढ़ रहा है, सो इसलिए TPC बढ़ता रहेगा. MCTC का फॉर्मूला लिखोगे W इंटू जी एम एल अपॉन 100L, राइट, डायरेक्टली प्रोपोर्शनल टू डिस्प्लेसमेंट. जैसे ही ड्राफ्ट बढ़ेगा W बढ़ेगा एंड देयरफॉर MCTC बढ़ेगा. So basically you're writing the individual formulas of each quantum and then explaining why it is increasing with draft or displacement or both. ये आपको लिखना है सारा एक्सप्लेन करके. तो इट्स अ प्रीटी गिव अवे क्वेश्चन. तो अगर ऐसा ही ऐसा कोई क्वेश्चन आता है इसको शुरू में कर देना पहले ही, बिकॉज इसमें ज़्यादा टाइम लगेगा नहीं आपका. डायग्राम ज़्यादा ड्रॉ करने हैं, वो स्केच आपने नकल मारनी है इसमें से, किताब में से.
तो इसमें सबका स्केच और सारा का फॉर्मूला भी, और उसके रेस्पेक्ट में फिर एक्सप्लेनेशन में सर ट्रेंड भी बताना होगा कि कहाँ से कहाँ इंक्रीज कर रहा है और उसका रीजन क्या है, और फिर डिक्रीज क्यों कर रहा है.
बिल्कुल. तो एक्सप्लेनिंग ऑल दैट. तो एक स्केच बना दिया, ग्राफ बना दिया, एक एक्सप्लेनिंग बता दिया और एक फॉर्मूला बता दिया और फॉर्मूला को डिस्क्राइब कर दिया. दैट्स मोर देन इनफ. So for each part of the question, you will write 5, 5, 6, 6 lines. That's it, which is equal to 5, 5 marks. तो क्या कोई काट ही नहीं सकता कुछ भी इसमें. Nobody can cut it unless until you don't write certain point. For example, TPC में you don't write the formula for TPC. I mean that's understood कि you should write. MCTC का formula of MCTC वो आपको करा दिया है मैंने, दोनों फॉर्मूले कराए हैं MCTC के. तो दोनों को एक्सप्लेन कर दो. LCB का मैंने अभी आपको बता दिया हाउ इट इज कनेक्टेड. सिमिलरली फॉर द अदर्स एज वेल, LCF, सिमिलरली फॉर KMT. ये है